Lesson 1.7, Graphing Linear Inequalities. We'll represent solutions on a number line, including interval notation and inequality notation. We'll solve linear inequalities in one variable, and in day 2, we'll solve absolute value inequalities. When we write inequalities using interval notation, instead of symbols like greater than or less than, you're going to use brackets and parentheses. You would use a bracket if x can equal the boundary number in your solution. Brackets would be represented for an inequality that's greater than or equal to, or less than or equal to. You would use a parentheses for your interval boundary if x cannot equal the boundary number. If you have just a greater than or a less than, you would use a parenthesis as your boundary. Also, anytime you have negative or positive infinity, since x can actually never equal those values either, you would use a parenthesis. To put this to the test, we're going to convert each inequality to its interval notation. Here's how it works. Our first example, x is greater than or equal to 3. On a number line, you would use 3 as your boundary, and the greater than or equal to symbol means you'd use a closed dot for your boundary number. If the if the inequality points to the right, the arrow points to the right as well, which means it's going towards positive infinity. Since x can equal 3, and that's the smallest number, we write that first. We always write smallest to biggest, and we'll use a bracket. Since it goes towards infinity on the right, that's the boundary on the other side, we'll use a parenthesis. Let's try the next one. Negative 1 is less than x, which is less than 6. There's a boundary on each side. For your number line, then, you would do a boundary at negative 1 and a boundary at 6. Because of the arrows, however, we would use open circles. And we'd connect them anytime or anything between negative 1 and 6. Interval notation, we'd only use parentheses because of these inequalities. So we would have negative 1 as the boundary on the left, 6 as the boundary on the right, and both would be bounded, with a parenthesis. Our last example, 5 is less than or equal to x, which is less than 12. Again, if we were to describe that on our number line, we'd have a 5 and a 12. The 5 would have a closed dot, but the 12 would have an open dot, and x is in between. Again, anything that has that equal bar is a bracket for your boundary, and 5 is the lowest number, all the way up to 12, and since 12 doesn't have the equal part underneath, we use a parenthesis. Now let's work backwards. I've given you an interval notation answer. You write the inequality. Our first example now includes an infinity. Notice it says negative infinity on the left and then negative 4 on the right. For your number line then, infinity isn't a boundary value. It means that arrow is going to go on forever to the left. On the right-hand side, negative 4 would be the actual boundary. And because it has a bracket, we know it equals negative 4. Let's make that negative. It equals negative 4. And since it goes, my dot is not big enough, there we go. And since it goes towards negative infinity, the arrow would go to the left. So writing it in inequality notation instead of interval notation, anything that's to the left is less than negative 4, and that bracket means it could be less than or equal to. And that's your your inequality notation. For 8 and 9, we have a bracket on each side. That means for your number line, you would have a dot on each side, which means it can equal both of those and be anything in between. That means between 8 and 9, x would go right in the middle. It's bigger than 8, but it's less than 9 all at the same time and can also equal those values. In this last example, I want to change it up just a little bit. Change that bracket to a parenthesis. I'm not quite sure why I didn't do that before I printed these. So change that bracket to a parenthesis. For this example then, we know that negative 2 is the boundary on the left and it's a bracket. which means it can equal -2, but 11 on the right now has that parenthesis. That means it's an open dot, and the arrow goes in between. If -2 can equal with that bracket, that means it's less than or equal to x, but then 11 is that parenthesis boundary, we'd make it just less than 11. That is your inequality notation that matches the interval. When solving linear inequalities, keep these things in mind. Keep your variable on the left side. That way, the direction of your inequality, the direction of that arrow, will always match on your number line. They'll always go in that same direction. If you ever multiply or divide by a negative number, flip the direction of the inequality. And last but not least, always write compound solutions from least to greatest. You'll always have your smallest number on the left and the biggest number on the right. The last set of examples, solve each inequality. Get this, we're going to write our answers as an inequality and in interval notation. So we'll have two forms for our answer. And then we'll graph our solutions on a number line. Our first example, 5x minus 7 is greater than 3x plus 9. It said in the very first thing to think about when solving, keep your variable on the left side. That means I'm going to keep all my x's on the left. I'll move 3x to the left side. And I'm also going to add 7. I'm just going to do two steps at once here. Save some space. So the 7 cancels. 5x minus 3x is 2x. 3x's cancel. 7 plus 9 is 16. Last but not least, divide both sides by 2. And we get x is greater than 8. That is your inequality answer. If we say interval notation, the arrow to the right means it's going towards positive infinity. So it's going to start at 8. And because it's just greater than, we use a parenthesis. Since the arrow goes towards the right, it's going towards positive infinity. And infinity is always a parenthesis. That's your interval notation. On your number line, 8 is our boundary number, and because it's an open dot, because it's just greater than. And notice the direction of your inequality, it goes to the right. Your arrow will also go to the right. And there you go. Take a look at the next example. Again, we're going to follow that same idea. Now we have 1 minus 3 halves x is greater than or equal to x minus 4. Again, we want to keep our variable on the left-hand side, so I'm going to move the x on the right over to the left. This looks like it might be tricky. I'm going to also move that 1 over to the right. If we have negative 3 halves x minus x, we need a common denominator. So that's going to be negative 3 halves x minus, technically that's 1 over 1, which would then be 2 over 2 if I get a common denominator. Ugh, that looks messy. On the right-hand side, negative 1 minus 4 is negative 5. If we combine like terms, negative 3x minus 2x would be negative 5x over 2 is greater than or equal to negative 5. Anytime you have a fraction with a variable, the quickest way to get rid of that fraction is to multiply it by the reciprocal. The two negatives cancel out, the 2's cancel, and the 5's cancel. So we get x by itself. On the right-hand side, negative 5, I'll put over 1. We'll just make it a fraction. And the 5's cancel, and the two negatives make a positive. X is greater than or equal to 2. There is your inequality answer. Now, to make that an interval with that the equal bar underneath, we're now going to use a bracket. Whoops, I don't know why I used red for that. I want purple. Let's go back. Bracket, the 2, and then because the arrow points to the right, again, it will go towards positive infinity, but that gets a parenthesis. On the number line, we use 2 as our boundary. X is greater than or equal to 2, so we use a closed dot to represent that, and our arrow points to the right. Our last example is called a compound inequality. And that means you have boundaries on each side. So it's a compound inequality, even though it doesn't look like I can spell that correctly. It was spelled correctly, just smudged. There we go, compound inequality. What that means is we'll actually have a boundary number on each side when we won't have that infinity. Let's see what we get. To get x by itself, we're going to need to get rid of everything on the inside that's happening to x. First, I'll add 1 to the middle, the left, and the right. -3 plus 1 is -2. In the middle, the 1's cancel, and we're left with 6x. And on the right, we have 6. Finally, to get x by itself, divide the left side, middle, and right by 6. -2 over 6 simplifies to -1/3. The 6 is cancel in the middle. On the right, 6 divided by 6 is 1. And that is your inequality answer. Now, to get that to be your interval answer, notice that the -1/3 is less than or equal to x. That means we would use a bracket, writing it smallest to biggest, all the way up to 1 on the right, and that's just less than 1, use a parenthesis. That represents your interval notation. And finally, to sketch the graph, I want a different color. Go back to my number line color. We have a boundary at -1/3 on the left side, a boundary of 1 on the right. It can equal -1/3, and it can't equal 1, but x is in between, and that's where we would go up over. And that's graphing inequalities with one variable.